Nearly 1 billion Egg McMuffins are sold around the world every year, making this humble sandwich McDonald's breakfast king, generating more than $10 billion in annual revenue. But have you ever wondered how an Egg McMuffin is actually made, transforming from what was once considered nothing more than a rushed breakfast into the product that completely changed perceptions of fast food breakfast? That journey begins in the vast wheat fields of the United States, where wheat is harvested and milled into the flour that gives the English muffin its signature texture. From there, every ingredient moves into modern processing facilities, where the meat, eggs, cheese, and flour pass through high-speed production lines before coming together to create one of the world's most iconic breakfast sandwiches. Today, join Agriculture Insight as we go behind the scenes of the Egg McMuffin and discover how these everyday breakfast ingredients are transformed into the fast food classic that has taken the world by storm. Let's get started. Today, breakfast has become a gold mine worth tens of billions of dollars for the fast food industry. Yet few people know that before the 1970s, the morning hours were largely ignored by most fast food chains because they believed customers would only spend money on burgers and fries at lunch or dinner. At that time, McDonald's franchise owner Herb Peterson was pursuing a bold idea, turning breakfast into a meal that could be served at industrial speed. Then, in 1971, the Egg McMuffin was born, a small sandwich that would later launch the breakfast fast food revolution around the world. To create its nearly perfect round egg, Peterson even hired a metal worker to make a special steel mold that allowed each egg to fit neatly inside the muffin. That extreme uniformity is exactly why many people still believe the egg in an Egg McMuffin is artificial rather than real. What makes it especially interesting is that, unlike many fast food items associated with thick sauces, grease, and layers of ingredients, the Egg McMuffin revolves around just a few basic components: a muffin, an egg, meat, and cheese. Yet this minimalist formula has helped McDonald's generate more than 25% of its revenue in many markets, even once threatening the position of its iconic burger lines as the company's main revenue driver for decades. To create the muffin used in an Egg McMuffin, the process actually begins in the seemingly endless wheat fields of Kansas, where every summer turns into a massive race to produce flour that meets the standards required for the muffins served in millions of McDonald's breakfasts each day. As soon as the wheat turns a deep golden color, enormous combine harvesters move into the fields. The cutting blades at the front sweep close to the ground, pulling the entire stalk into the processing chamber, where the grain is separated and cleaned almost immediately. A modern machine can process more than 90 tons of wheat per hour, while trucks driving alongside continuously receive grain from the unloading auger, allowing the harvester to keep moving without stopping for even a few seconds. The entire process must be carried out with extreme speed and precision because even a small change in moisture content can noticeably affect the quality of the flour produced later. After leaving the fields, the wheat is unloaded into underground receiving pits before passing through a preliminary cleaning system. At the mill, the wheat first moves through a high-speed cleaning system that removes stones, dry straw, dust, and defective kernels. It is then transferred into silos standing dozens of meters tall, where its moisture content is stabilized under tightly controlled conditions for several hours. Next, the wheat passes through dozens of pairs of steel rollers rotating at different speeds, gradually separating the bran and germ from the protein-rich white endosperm inside. This endosperm then moves through a continuously vibrating plan sifter, equipped with multiple layers of ultra-fine mesh, where it is sifted and reground repeatedly until it reaches an almost perfectly uniform consistency. This is where the journey to creating the signature Egg McMuffin muffin truly begins. Unlike a regular hamburger bun, which only needs to be soft and fluffy, The muffin used for an Egg McMuffin must have enough elasticity and structure to hold the hot egg, cheese, and meat without becoming soggy or collapsing once assembled. That's why the mixing stage functions almost like a texture control system. The flour, water, and yeast are not simply blended together. Instead, their proportions are continuously monitored and adjusted to create thousands of tiny air pockets throughout the dough, forming the foundation of the muffin's signature honeycomb-like crumb. In large-scale bakeries, a single continuous production cycle can produce around 6,300 muffins. After mixing, the dough is continuously cut and rounded on high-speed chutes before being coated with a fine layer of cornmeal. This coating not only gives the muffin its distinctive aroma and texture, but also keeps the dough portions separated and prevents them from sticking as they pass through the heated molds and proofing chamber. The proofing chamber for Egg McMuffin muffins works like a life activation oven for the dough. Over approximately 45 to 60 minutes, the yeast becomes highly active, causing the dough to expand as if it were breathing while forming the muffin's signature honeycomb-like interior. After leaving the proofing chamber, the dough portions almost seem to burst into life as soon as they drop into the intensely heated baking molds. The muffins are first baked on the bottom in a tunnel oven, then flipped 180 degrees so the other side can be baked. Even a slight temperature variation can cause the internal honeycomb structure to collapse, turning the muffin from soft and springy into something dense and firm like ordinary bread. After leaving the oven, thousands of muffins rush into a massive spiral cooling system before being automatically scanned for color, size, and height in a matter of seconds. Any muffin that fails to meet the standard is immediately removed from the line, while the perfect ones continue moving like traffic on a multi-lane highway before being packaged and transported to McDonald's restaurants. A large factory can finish nearly 500,000 muffins per day just to supply the Egg McMuffins served the following morning. From the freshly finished soft muffin, the story of the Egg McMuffin moves to its savory filling, where Canadian bacon is carefully processed so that every slice placed inside the sandwich has the same thickness, tenderness, and smoky flavor. Here, fresh cuts of pork weighing up to 2,000 pounds are transported directly to the processing plant, where all hard bones, thick skin, and excess fat are removed, leaving only the lean loin with an extremely precise fat ratio. With Canadian bacon, even a slight variation in fat content can completely change the texture after smoking. From here, the meat enters the stage that determines nearly all of its final flavor: preparing and injecting the brine. Inside enormous stainless steel tanks, a mixture of salt, sugar, sodium nitrate, and coloring agents is continuously stirred in proportions controlled almost down to the gram. It is then pumped through a system of more than 120 fine steel needles that repeatedly pierce each cut of meat as it moves along the conveyor belt. Once the seasoning has fully penetrated the meat, it moves into the shaping area, where each lean cut is tightly pressed into a cylindrical steel mold to create the signature round shape of Canadian bacon. A caramel-coated netting is then wrapped evenly around the outside, helping the meat hold its form throughout the heating process, while giving the surface an appealing glossy brown color. From there, the meat enters a slow cooking chamber for nearly 5 hours at a low temperature, allowing the heat to reach deep into the center without drying out the lean fibers. Once cooking is complete, the meat is rapidly chilled to lock in its structure. The outer netting is removed, and the logs are sent directly to an automatic slicing machine. Within seconds, high-speed blades cut each piece into uniform round slices, about 1/4 inch thick, so precisely shaped that they seem almost specially designed to fit perfectly inside McDonald's famous Egg McMuffin. But to turn all these components into a complete Egg McMuffin, one essential ingredient remains: the perfectly round egg at the center of the sandwich, which is largely responsible for its signature soft and moist texture. Contrary to what many people believe, Egg McMuffins are not made with powdered eggs or industrial egg mixtures. At many McDonald's restaurants across the United States, each egg is still cracked fresh onto the grill right in the kitchen. From the moment it is laid, an egg begins its journey along an underground conveyor system stretching roughly 700 meters, with almost no human hands touching it. Throughout that journey, every egg passes through multiple inspection stages. Cameras detect microscopic cracks, rotating brushes clean the entire shell, drying and UV sanitizing systems disinfect the surface, and high-intensity LED lights shine through the shell to reveal any internal defects. Only eggs that meet nearly flawless quality standards are sorted, packaged, and shipped to McDonald's kitchens, where they become the signature soft, moist egg layer inside the Egg McMuffin. And once the muffin, Canadian bacon, and egg are ready, one final piece remains to complete the Egg McMuffin: the slice of soft, melted cheddar that gives the sandwich its signature richness and creamy texture. The process begins as large blocks of cheese are shredded on high-speed conveyor lines. Throughout this stage, the temperature is carefully controlled to prevent the cheese from softening or losing its shape due to friction. The cheese is then transferred to a heated mixing vessel, where water and emulsifying salts allow the fat, proteins, and moisture to blend into a smooth, pliable cheddar. The mixture is poured into molds, cooled, and sliced into pieces of nearly identical thickness, while camera systems continuously monitor the line for even the slightest variation. Finally, each slice of cheddar is wrapped in a protective film and rapidly chilled to preserve its structure before robotic systems automatically package it and ship it to McDonald's restaurants. Each Egg McMuffin begins with an English muffin that is quickly toasted until lightly crisp on the inside while remaining soft on the outside. The Canadian bacon is seared, while a fresh egg is cracked into a round mold and steam cooked for about 2.5 minutes. When an order is placed, the hot muffin, cheese, egg, and meat are assembled in just a few seconds, creating McDonald's iconic breakfast sandwich that has remained popular for more than 50 years. If M&M's was born from the Mars Empire and Hershey's grew up alongside America's iconic chocolate factories, Dubai chocolate began with a very ordinary idea. In 2021, Sarah Hamouda, a British-born woman living in Dubai, wanted to turn the flavor of natha tied to her childhood memories into a new kind of chocolate bar by combining. No one expected that this handmade candy would later be amplified by TikTok into a craze with more than 120 million views, pulling the whole world into the hunt for this luxurious sweetness. Dubai has always been a place where everything can be pushed to a level of extravagance, from supercars and gold-plated hotels to gold-plated toilets made simply to assert wealth. So when Dubai chocolate appeared, it did not enter the market like an ordinary candy bar. Each official bar costs around 18.6 USD, several times more expensive than common chocolate in the United States. But the real shock is that this craze also helped push pistachio prices up by more than 34%, turning pistachios into the new viral star of the global confectionery industry. The journey of Dubai chocolate does not begin only in luxury stores or million-view videos, but in large-scale pistachio-growing regions stretching across the hot, dry climate of California, the world's largest pistachio production center. Today, the United States accounts for about 61% of global pistachio production, with nearly all of that output coming from California, especially hot, dry valleys such as the San Joaquin Valley. Iran and Turkey remain two major rivals, but California has risen to the top thanks to farms spanning hundreds of thousands of acres, precision irrigation technology, and a harvesting system that is almost fully mechanized. There was a time when pistachio harvesting was an extremely labor-intensive job, with hundreds of workers using long poles to continuously knock the nuts from the trees under the late summer heat. But today, modern shaking machines have transformed the entire process into a high-speed production line, where each tree can be almost completely harvested in just a few seconds. In September, in California's San Joaquin Valley, the pistachio harvest officially reaches its peak. Hundreds of thousands of hectares of pistachio orchards shake under temperatures nearing 38 degrees Celsius, bringing in tens of thousands of tons of pistachios in a single harvest day. All of this is made possible by these mechanized giants worth hundreds of thousands of dollars. First, the harvesting machine approaches and moves along perfectly aligned rows of trees. As it reaches the trunk, the hydraulic clamp opens and tightly grips the base with thick rubber pads, helping transfer the vibration without tearing the bark or damaging the wood tissue. Immediately afterward, the shaking system generates an extremely powerful vibration force that can exceed 35,000 newtons, equivalent to the combined pulling force of several small cars. This force travels from the trunk up into the branches, causing tens of thousands of ripe pistachios to detach from their stems all at once. In just a few seconds, the entire canopy seems to release a rain of pistachios. Below, large catching frames immediately close around the trunk, collecting the nuts before they touch the ground. From the giant catching frames, the pistachios are pushed onto the conveyor system built directly into the harvesting machine. As the conveyor vibrates gently, leaves, small twigs, dust, and empty nuts begin to separate from the main flow of pistachios. Some machines also use powerful air streams to blow away lighter debris, allowing the nuts to be roughly cleaned right in the orchard without stopping the machine. After that, the pistachios slide through guide chutes and drop straight into large plastic bins. This continuous process not only reduces losses in the orchard, but also minimizes the time the nuts spend under the late summer heat. In 1 hour, this modern harvesting system can cover nearly 2 hectares of pistachio orchard, collecting more than 3 to 6 tons of fresh pistachios while requiring only 2 farmers to monitor the entire process. What makes pistachios special is that after harvesting, they must be processed extremely quickly. If the soft outer hull is left on too long, it can stain the hard shell underneath, directly affecting the selling price. As soon as the plastic bins are filled with pistachios, specialized forklifts quickly lift each bin onto large transport trucks. Some mega-scale farms also use mobile pistachio receiving conveyors to transfer the nuts directly from the harvesting machine into trailers, without the need for intermediate plastic bins. Within about 4 to 6 hours, the entire freshly harvested crop is transported to processing plants. Here, conveyor systems receive the pistachios from the trucks and carry them straight into the factory through enclosed chutes, where the continuous flow of nuts is spread evenly, speed-controlled, and cleared of any remaining large debris before being dropped directly into large water tanks to wash away soil, dry leaves, and fine dust still clinging to the soft outer hull. Immediately after washing, the nuts are sent through a system of high-speed rotating rubber rollers to remove the soft outer hull. This is an extremely important step because if this hull remains attached for too long, its pigments and moisture can stain the hard shell underneath or lead to mold growth. After float sink separation, the pistachios are dried and then transferred to vibrating screens and optical camera systems for sorting, combined with the hands of skilled workers to select the greenest, plumpest, and most perfect nuts. Finally, the hard shell is removed, leaving only the green kernel inside, which continues through manual sorting to eliminate any kernels that do not meet quality standards. The qualified kernels are then roasted with powerful streams of hot air in industrial ovens, allowing the signature rich aroma of pistachios to fully develop, while making the kernels crunchier and more flavorful. After reaching the perfect crunch and richness for Dubai chocolate filling, Pistachios can be packed whole for high-end restaurants to process themselves, or ground before packaging. Another form is to grind them directly into a smooth paste to be mixed with cream. The smoother, more naturally green, and more intensely roasted the pistachio cream is, the better it combines with crispy Kataifi, creating a rich, nutty filling with the perfect contrast against the outer chocolate coating. The soul of the pistachio filling is now complete. Next comes Kataifi, the crispy personality that creates the addictive crack and transforms Dubai chocolate from a rich candy bar into a global food phenomenon. The Kataifi strands in Dubai chocolate begin with a mixture that may seem very simple, but actually requires extremely high precision to create hair-thin strands. Flour is poured into a stainless steel mixing tank along with water, then a small amount of salt and oil. A mechanical mixing arm, fitted with a round agitator, continuously stirs in a swirling motion from the center toward the edges of the tank, allowing the batter to blend evenly without forming lumps. Once the mixture reaches a thick consistency, water is added little by little while the batter continues to be stirred until it becomes thin, smooth, and flows evenly. After that, the mixture is transferred to a batter homogenizing tank, fitted with a vertical shaft and a round mixing disc at the bottom. During operation, the disc continuously rotates while moving up and down, creating an even vortex inside the batter. This motion helps break down any remaining small lumps, keeps the mixture smooth, fluid, and prevents it from settling at the bottom before it is transferred to the Kataifi strand spraying machine. When the batter is ready, the artisan pours the liquid mixture into a Kataifi forming machine, where dozens of tiny nozzles underneath transform it into silk-like strands across the surface of a continuously rotating hot plate. After only a few dozen seconds, once the strands fully cover the hot surface, the artisan skillfully lifts the thin layer of Kataifi by hand or with a long stick, lets it cool, and gathers it into light bundles. Although it may look gentle and effortless, the process is actually extremely difficult. A small technical mistake can ruin the entire batch of Kataifi instantly. In large-scale Kataifi factories, the process is generally the same. The difference is that the machinery is fully automated, from batter mixing and filtering to strand spraying and cooling, allowing production to run 10 to 20 times faster than traditional handmade workshops. However, handmade Kataifi is often more expensive because the strands have a more natural texture, greater airiness, and a more distinctive crispness. After being finished, the Kataifi is sealed in airtight packaging to preserve its dryness, ready to be sent to chocolate workshops, where it will be roasted with butter, mixed with pistachio cream, and transformed into the signature crispy filling that gives Dubai chocolate its unique appeal. As a premium product with a fresh filling and a complex multi-layered structure, Dubai chocolate is mostly made in artisanal chocolate workshops, high-end bakeries, or boutique dessert stores. After enough couverture chocolate, pistachio cream, tahini, butter, and dried Kataifi have been prepared, the process begins by melting the chocolate in a tempering machine to create a smooth, glossy, and stable liquid mixture. Meanwhile, the Kataifi is chopped into small pieces and toasted with butter in a large pan until it turns golden, dry, and crispy. This Kataifi is then mixed with pistachio cream and a little tahini, forming a rich green filling that is fragrant, creamy, smooth, and distinctly crunchy. Once the chocolate is ready, the chocolatier pours a layer of liquid chocolate into the mold, spreads it evenly, and chills it quickly to create a thin outer shell. Then, the Kataifi pistachio filling is added to the center of the mold, before a final layer of chocolate is poured on top to seal the entire filling inside. Finally, the chocolate bars are chilled until fully hardened, removed from the molds, checked for surface quality, decorated with a little edible gold leaf to enhance the luxurious feel, and packed in premium packaging before being sent to stores or delivered to customers. Many people believe Dubai chocolate is too expensive for its actual taste, and that its rich filling can even become overwhelming quickly. But many others are fascinated by its crisp chocolate shell, thick pistachio filling, and addictive crack sound, to the point that they are willing to pay a high price just to try it. So which team are you on? Team Dubai chocolate is overhyped? Or team, I'd hunt down this viral chocolate at any cost? While Brazil holds more than 230 million cattle, a vast living reservoir, the United States takes a completely different approach. Not raising more, but transforming meat into value. Each year, over 200,000 tons of beef are dried and condensed into convenient jerky, traveling across interstate highways to convenience store shelves around the world. Few people realize that beef jerky is one of the oldest forms of portable protein, dating back more than 2,000 years, beginning when the Inca hung meat in the cold winds of the Andes. Since then, these small strips have moved through history, spreading across continents and becoming a globally consumed food. Beyond its historical value, these thin slices function as a compact biological energy source, where protein is concentrated to levels that can be up to 3 times higher than eggs and far exceed fresh meat, which still retains water. As a result, each strip becomes a refined form of energy, dense, efficient, and quickly absorbed by the body. And to turn those small strips of meat into a massive multi-billion-dollar industry, everything doesn't begin in factories. It starts on the farms. Right now, let's head to the Texas Panhandle, one of the largest beef-producing hubs in the United States, where each animal is not just raised but monitored like a mobile data point. Here, cattle don't simply grow, they emit signals. From movement patterns and daily feed intake to the slightest behavioral changes, everything is continuously recorded through chips and sensors, allowing control centers hundreds of kilometers away to track thousands of animals in near real time. Across grasslands stretching to the horizon, breeds like Angus and Hereford develop steadily before entering feedlots, the acceleration phase, where diets are no longer left to nature but are precisely calculated down to the gram. Ground corn, energy-rich byproducts, and trace minerals are mixed within minutes, yet enough to feed hundreds of cattle per batch. As feed trucks move along the troughs, rations are laid out in continuous lines, synchronizing feeding behavior across the herd and maintaining consistent daily weight gain. Interestingly, even what seems like waste, such as melon rinds or corn cobs, is recycled into usable energy. Every day, tons of byproducts are reintegrated into the system, reducing waste and optimizing costs. And when everything connects, what emerges is no longer traditional farming, but a vast, data-driven production system. After approximately 120 to 180 days of finishing, once each living data point reaches its optimal threshold, the journey doesn't stop. It shifts into the next phase: transportation. The cattle are guided through narrow, curved chutes that leverage their natural instincts, allowing them to move smoothly while minimizing stress before loading. Transport trucks are divided into multiple, ventilated compartments with anti-slip steel flooring to maintain stability over distances that can reach up to 500 kilometers. And just minutes after each trip, every compartment is thoroughly cleaned, ready to continue the next cycle. A continuous flow with virtually no downtime. Leaving the grasslands after a journey of hundreds of kilometers, the cattle enter the most critical stage of the production chain, the processing facility. Almost immediately, the carcass is transferred onto an industrial splitting line, where a high-speed saw, operating at up to around 3,000 revolutions per minute, precisely cuts along the spinal axis within seconds. From here, each half is separated and moved into subsequent stages of sorting, trimming, and processing, where every cut is directed towards specific uses across the entire production chain. As soon as it leaves the main processing area, the carcass is transferred to the cutting stage, where raw materials are specifically prepared for beef jerky production. Here, the meat is not cut randomly, but separated along the natural grain direction to preserve muscle structure, a key factor that directly influences shrinkage and shape during drying. First, muscle groups from the shoulder and upper chest are prioritized, as they contain long, relatively uniform fibers, forming the foundation for jerky pieces that retain a stable shape after drying. Next, selected portions from the hind leg, rich in natural collagen, are incorporated to create the characteristic chewy and elastic texture. At the same time, the meat is inspected for color and lean ratio to ensure freshness and consistency before moving on to fat trimming and marination in the next stage. At this transition point, the production line moves into the trimming stage, the quality shield of the entire beef jerky process. Trimming always begins with the removal of nearly all visible fat, because even a thin strip just a few millimeters thick can significantly shorten shelf life after drying. The reason lies in the fact that lipids in fat oxidize much faster than lean meat proteins, leading to rancid odors and reduced product quality. For this reason, workers carefully remove the white fat layers, while also eliminating coarse muscle bundles, large tendons, and dense connective tissues, to retain only the most structurally stable meat. At this stage alone, up to 15 to 20% of the initial mass may be removed, but in return, it creates the foundation for clean, chewy beef jerky that can be stored reliably for months. After trimming, the meat is fed into a multi-blade industrial slicer, where continuously rotating blades cut along the natural muscle grain, producing slices with a near gold standard thickness of 4 to 6 millimeters. This precise thickness allows the jerky to form clear fibers after drying, maintain a clean shape, and achieve the characteristic chewy texture without becoming overly dry or brittle. Following slicing, the meat strips may be rinsed and briefly blanched in hot water for about 1 minute to clean the surface, reduce microbial load, and slightly firm up the muscle fibers. However, this step depends on the production facility and is not mandatory in all beef jerky processing lines. After the removal of fat and tough connective tissues, the meat immediately enters the flavor-locking stage, a critical step that defines each brand's identity. Inside vacuum tumblers, salt, sugar, pepper, garlic, and soy sauce penetrate deep into the muscle fibers within just 20 to 30 minutes, then building a rich flavor base before drying. It is at this stage that each producer holds its own secret formula. Jack Link's leans toward a bold, savory profile typical of classic American-style jerky, while Old Trapper stands out with its signature lightly sweet, smoky flavor. After seasoning, each batch of meat is placed into sealed stainless steel tumblers, rotating at dozens of revolutions per minute. This continuous motion ensures the marinade doesn't just coat the surface, but begins penetrating deep into the muscle fibers. The real game changer, however, lies in the mechanical needle tenderizing stage. Within just 5 to 10 seconds, hundreds of fine needles pierce the surface, creating pathways that allow the seasoning to reach deep inside the meat. Depending on the facility, the marination process may be repeated 1 or 2 more times, effectively forming a multi-layer flavor lock, so that by the time the meat enters the drying chamber, the richness is no longer just on the surface, but fully embedded within every fiber. After marination, the meat slices are not simply loaded into the dryer. They must be carefully arranged layer by layer, almost like a thermal map, to ensure each piece dries evenly down to the millimeter. The slices are spaced about 3–5 millimeters apart, allowing hot air to flow across the entire surface. Even a slight misalignment in a single tray can cause an entire batch of hundreds of kilograms to dry unevenly. Because inside an industrial dryer, air is the true chef behind beef jerky. In some production lines, instead of laying the meat on trays, the strips are hung vertically on stainless steel rods using metal hooks, allowing hot air to circulate evenly around both sides at the same time. Once the meat is neatly arranged on trays, the entire batch is transferred into the drying chamber. From that moment on, the meat never touches direct flame. Instead, it enters a tunnel of hot air, where temperature is precisely controlled down to each degree Celsius. Streams of air at 50 to 70 degrees Celsius continuously pass through every layer of meat for 6 to 10 hours, drawing moisture out from each muscle fiber. By the end of the process, the meat can lose up to 60% of its original weight, and it is at this point that fresh meat is truly transformed into beef jerky. After leaving the drying chamber, the jerky strips may retain their signature long form. However, in some brands such as Jack Link's, they continue through an industrial cutting system where the strips are processed within seconds into uniform snack-sized pieces of around 2 to 5 centimeters, ready to move onto high-speed packaging lines. After leaving the sizing stage, the beef jerky moves into the final packaging process. Here, each bag is inflated with clean air to maintain its shape before receiving the product. Within seconds, the jerky is filled in standardized portions of 30 to 50 grams per bag on high-speed packaging lines, while workers perform quick checks on color, dryness, and weight to ensure batch consistency. Immediately after, the bags are vacuumed and fully sealed, creating a stable environment that limits oxidation and preserves the product's characteristic flavor. This seemingly simple step acts as the final lock of the entire process, allowing the jerky to be stored for 6 to 9 months while maintaining its chewiness, aroma, and fibrous structure almost intact. Do you like fish sticks? Yes or no, of course. But for hundreds of millions of people in the United States, the UK, Germany, and many European countries, fish sticks have gone far beyond a simple convenience food, becoming a staple of family meals, school menus, and mainstream food culture. In the UK alone, the birthplace of fish fingers, 75% of children eat fish sticks before ever tasting fresh fish for the first time. Back in the 1950s, when Gordon's launched the fish stick as a lifesaver for mountains of frozen seafood inventory, the product was considered hard to swallow, and almost nobody wanted to buy it. Yet only a few years later, its sales exploded to the point that it once threatened even the throne of canned meat in the world of industrial food. Today, with a near GOAT status in the frozen food industry, fish sticks generate more than $3 billion USD a year and continue expanding their influence globally. Many people confuse the taste of fish sticks with chicken nuggets, but in terms of nutritional value, fish sticks clearly come out on top thanks to their richness in omega-3, low saturated fat, and virtually no added sugar. Meanwhile, compared to imitation crab sticks, fish sticks earn even more points because they are made from real pollock fillets, preserving their natural flavor and firmer texture. And every journey needs a starting point. For fish sticks, it all begins in the Bering Sea, one of the coldest and harshest waters on the planet, yet a strategic resource hub for the global fish stick industry. Lying between Alaska and Russia, the Bering is a harsh natural boundary connecting the Pacific Ocean with the Arctic Ocean. This is a deep, cold body of water constantly struck by strong winds, drifting ice, and fierce winter storms. making it one of the most challenging fishing grounds in the world. Yet this very harshness nurtures a nutrient-rich ecosystem, where diversity and dense biological productivity turn the Bering into a rare natural reserve of seafood, allowing migratory species, especially Alaska pollock, to reach immense stock levels. Although there are hundreds of fish species offshore, fish sticks in fact revolve around only a few main names, of which Alaska pollock accounts for up to 90%. The rest are hake, cod, and haddock. All of them are white meat fish, low in bones, easy to fillet, and cheap enough to meet an annual output of millions of tons. Every January, the Bering Sea boils with modern factory trawlers more than 113 meters long, with capacities of up to 6,000 horsepower, where seasoned fishermen are ready to conquer migratory fish schools, numbering in the billions. Modern fishing has become a game of technology, completely beyond the realm of luck. Natural signs such as flocks of seagulls swooping down to the water, once the familiar code fishermen used to guess the location of fish schools, are no longer the only tools for tracking the traces of massive migratory fish. Replacing them are deep-scan sonar systems, surface radars, and high-frequency echo sounders, creating a living map of the underwater world in real time. On deck, specialists constantly monitor wave-scan displays and ultrasonic detectors, devices sensitive enough to accurately outline every movement of entire fish schools hidden deep below the seafloor. When the image appears, with dark bands sweeping across the screen like a living cloud of the ocean, the captain immediately orders the nets to be released. Midwater trawl nets, the ultimate weapon of the modern industrial fishing industry, are deployed with near-perfect precision. With a mouth diameter hundreds of meters wide and a height equivalent to a 10-story building, the net is released, opening like a giant steel funnel in the ocean. When the net closes, the entire fish school is gathered in an instant. The bottom of the net is tightened by a cable system, sealed as if tying the mouth of a bag, then slowly hauled to the surface. The back-breaking work of net hauling in the past has now been replaced by automatic hydraulic winches that pull up hundreds of tons of fish with just a single control button, not only saving labor, but also increasing productivity and output by hundreds of times. Within minutes, hundreds of tons of pollock thundered down onto the deck, powerful like the discharge of a dam. On the processing floor, the intake funnels open wide to catch the dense stream of fish flowing straight into the ship's hold, where a floating factory is already waiting to begin a mass processing sequence for the newly captured haul. Inside modern factory trawlers stretching over 100 meters, nearly 3/4 of the space is dedicated to processing and freezing, turning them into true floating factories capable of handling up to 300 tons of fish per trip. The moment the catch hits the deck, a race against time begins. Pollock must be processed within minutes to preserve optimal freshness. From the intake chute, the fish move on to the conveyor system, where a stream of water continuously washes away blood, debris, and surface mucus before they are routed into automatic grading channels based on size, weight, and body shape. At each sorting gate, fish drivers stand by, guiding the flow into the correct processing lanes to prevent blockages and maintain uninterrupted throughput. After grading, the fish are sent to the automatic gutting machine, where a high-speed rotating blade slices along the body, removing the viscera in just a few seconds per fish. Next, the head-body bone separation system operates continuously, processing more than 100 fish per minute. This workflow ensures that the resulting fillets are almost completely free of fine bones, an essential requirement for fish stick production. The fillets then move on to the candling stage. Each piece is examined under intense light from an illuminated table to reveal any remaining bones, blood spots, or tissue defects. Skilled workers at the candling stations quickly remove these small imperfections, a seemingly minor step, yet one that ultimately determines the final quality of the fish block. The qualified fillets are then packed into rectangular fish blocks, weighing approximately 7 to 9 kilograms, with uniform flesh density and precise thickness. This is the standardized raw format that allows hundreds of perfectly identical fish sticks to be cut later on. The blocks are fed into a plate freezer, a dual-surface freezing system using high-pressure steel plates. The core temperature drops within just 2 hours, forming ultrafine ice crystals that preserve muscle structure and minimize moisture loss during thawing. This is a decisive advantage for quality when the blocks are brought ashore for further processing. The vessel's cold hold stores hundreds of tons of fish blocks throughout the voyage, ensuring no thermal loss even as the ship operates continuously for weeks. The long journey at sea for these frozen fillet blocks officially ends when they are brought ashore and sent directly to the fish stick processing plant, the final and most demanding stage in the production of this convenient food. At the plant, each received fish block undergoes a strict incoming quality check. Specialists measure the block's dimensions and weight, verify core temperature, flesh uniformity, color, and moisture loss. A sample block is partially thawed to assess texture, odor, and any remaining pin bones, ensuring the material meets all standards before entering production. After passing the inspection, the fish blocks are moved to the slicing area, the first step, and the one that defines the overall structure in the production of fish sticks. On the slicing line, the frozen fillet blocks are fed through a high-speed bandsaw, dividing them into fillet sheets of uniform thickness before the automatic cutting system takes over and slices them into hundreds of sticks with millimeter-level precision, 10 to 12 millimeters thick, 20 to 25 millimeters wide, and 60 to 90 millimeters long. This exacting precision is essential for achieving perfect consistency in the subsequent coating, frying, and freezing stages. Once shaped, the fish sticks move into the coating line, where their crust is built through 3 consecutive layers that define the final crisp texture. First, each freshly cut stick is completely covered with a thin layer of batter, ensuring even adhesion from end to end. Next, the sticks pass through a dry coating layer, which stabilizes the surface and creates a firm base for the final stage. A generous coating of golden breadcrumbs that will produce the signature light, crunchy bite after frying. Throughout the process, sensor-controlled spraying and rolling systems closely monitor and maintain the optimal coating thickness, ensuring that every finished fish stick expands evenly, fries to a uniform crispness, and achieves consistent quality across the entire batch. After coating, the fish sticks are quickly fried for no more than 30 seconds. This par-frying technique sets the outer crust while keeping the interior frozen. The goal is not to cook the product, but to lock in its shape, ensuring each stick remains intact during freezing and transport. When a fish stick snaps with a crisp break, while the interior remains firm and white, the par-fry level is considered perfect. Immediately after the par-fry stage, the fish sticks enter the IQF system, individual quick freezing. Powerful blasts of ultra-cold air freeze each stick solid within just a few minutes. During the process, the sticks remain separated, preventing any clumping. IQF technology ensures not only free-flowing products but also preserves the muscle structure, moisture content, and overall quality throughout storage and transport. Once the freezing stage is complete, each fish stick moves into the automated packaging area, the final step before leaving the production line. Here, the sticks are checked for weight using high-precision laser sensors, then transferred directly into a fully robotized packing system. Robotic arms handle the arranging, positioning, and sealing of bags or cartons at a steady pace, allowing the line to reach a capacity of 4,000 to 6,000 boxes per hour, depending on the plant configuration. After packaging, the entire batch is moved into the cold storage area, where it waits for distribution across the globe while maintaining its original quality. From the vast pollock schools of the Bering Sea to the deep freeze precision of processing lines, each stick represents a blend of natural nutrition and carefully controlled technology. But like all industrial foods, it carries its limits. The added batter, oil, and sodium call for mindful selection and moderate consumption. When used wisely, the fish stick becomes more than a quick meal. It becomes a balanced part of contemporary eating, where flavor, nourishment, and responsibility toward our own bodies are meant to coexist.